So welcome to the second day of our challenge, and today we're going to talk about a project that will give you a very good idea about how a machine learning model implementation works from end to end. And we're going to talk about specifically classification problem. For those who don't have idea about the classification, just very simply, we have supervised machine learning and we have unsupervised machine learning. For the supervised machine learning, the information or the data that we provide to the machine learning models, they have labels in it. So we are already providing the answers to the models. So if you're giving some features and you're telling what is the right answer. So if the model looks into a lot of data, then it can make prediction. So supervised, it means the data has been supervised by a human, right? And there are two basic types of supervised machine learning. One is classification, another one is regression. I'm not going to go into the detail, but classification, as the name suggests, it will output class. That's it. If you look at the diagram, it's try to classify the data into two classes. So here we have more greens. So this is one class, and there are more dark green, and there are excuse me second class. So this is a classification problem. But for the regression, what it does is we're trying to predict a continuous value. It's trying to give us a value. So if you look into certain point, look at 80, and it's trying to give you a predicted value of 65 or 70. So the regression will give us a value, and a classification will give us a class. So today with the workthrough, we're going to actually work on the classification problem. And the next day, we're going to work on with the regression problem. So today we're going to just predict a class. So the data set that we're going to look into is a famous data set, and this is most likely a hello world problem in the machine learning world when you start working, and that is the Titanic survival prediction data set. And we need to have a basic idea what the data does, right? And I will show the data, but basically it has these columns, and these are the description. So passenger ID, the passenger's identification, then whether the passenger survived or not, what is the class of the ticket, P class, the name, the gender, the age, the sibling or spouse traveling with the passenger, the parent or children traveling with the passenger, the ticket number, the price of the ticket, and the cabin number. And the classification question that we're going to ask, based on all this information, we're going to say whether the passenger survived or not. See, whether the passenger survived or not, that is the question, the prediction will be made. So this is a classification problem, right? And we need to go through the few steps that we're going to work on, and let's look at the data. So nothing to worry about. I just run the code into the Google Colab, and I'll share the link. You can easily run this code. The core idea is not to understand everything, but to grasp the idea how things work. Because if you know how to solve the problem, you can find the code anywhere you want. And the first chunk that if we look into, this is just importing some useful libraries. And you don't have to memorize or understand everything, but the matplotlib pyplot, that basically helps us to make some plotting, number one. Then if we do work with some data frame, then the pandas actually helps a lot. So pandas is from to working with the data set. Then if you see, the sklearn library has been used in 3 times. So that is scikit-learn, and it has a lot of modules, and we're going to selectively use a lot of part. There, first of all, if you look, it is trying to import ensemble. Ensemble is when you try to combine multiple machine learning models. Then you can use the ensembles. Then you have the tree, where you can use to get some models, tree-based models, do some pre-processing features, and the model selection. And the matrix one is actually to help us to evaluate the model. So when you have a model and it predicted some values, we can calculate the area under the curve, or AUC, look into the confusion matrix, how many correct prediction did it make or not, and so on. And there are more. Then we have the model selection. Model selection actually helps us, number one, the train test split. This actually helps us to, the name suggests, is that if we're trying to split the data set into 2 different parts, like 80-20, it will help us. Stratified k-fold, it actually makes sure that if you are partitioning the data set into different parts, those individual parts, they are close to or identical to the original data set. What I mean by that is, if the original data set has 80% positive class and 20% negative class, and if we subdivide it into 3 different parts, those 3 different parts will also have 80-20 ratio. So it's more homogeneous nature. And yellow brick is just personal choice, is to visualization, when we'll see. So we just, first step, we imported some libraries. Simple. The next one is, we have to train the model. The most important part of the model is we need to, I think it will be better if I share that image with you guys, because that will make more sense. Yeah. So we have to collect the data. The first step, if you go back to the challenge 1, the data collection phase, where we ask what data exists, where we can get it, is it public, are there any privacy concern, is it structured or unstructured, right? And mostly for the supervised, we need a structured data because we need the labeling. Unstructured data is when you don't have the structure, like images or voice, you know. So we look into that. So the data is publicly available, and we get the link to that, and we put it into a variable, and we use the pandas to read the Excel file. So if it was .csv, we would call read underscore CSV. We are basically in this chunk, we are hitting this URL, and we are returning into a data frame. And DF is the convention, short convention of the data frame. But initially, when you make a call, if you have the data set, you call it DF. And as we're going to work with different exercises, we save the original data set under this variable. So this is optional, but when you want to have the original copy of your data set, you can keep it like that. So we have the data set now. Now when you put the data set, when you have it, then we do the data preparation. For the data preparation phase, we do EDA. This is a term that you can memorize, exploratory data analysis, when you go through different parts and try to see what should be done to prepare the data, and what is the pre-processing and the splitting we need to do. And I'll show the steps. So we have the data. So the first thing we could do is we just run the data types, right? And it will actually spits out this columns, right? Oh, it didn't work because I didn't run this. It should not work because I didn't run this. So let's run this. I'm importing the library, so it's got the green mark. Now it should work. Yeah. So now the data is fetched, it's working, the Titanic dataset, and it shows us the name of the columns. Or in the data science world, we call it features. So P class, survived, name, sex, age, sibling, spouse, parents, children, ticket, fare, like I showed. All the informations, right? We found it. So for the first question, we know, okay, these are the information that we have, and we can cross check if you want, if I get all the things correctly, right? We have the features. Now we want to know how many instances or examples are there or samples are there. So these are the columns, and we want to see there are 1309 rows are there or samples, and 14 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are total 14 column, and it matches, right? So the moment we have the data, we know the columns and the row number. The columns are called features, the rows are called samples. And now if you look carefully, the P class is int64, so we're expecting a number. So this is a number, and as these are int64, it means there is no missing values. But when you have objects, it could be a string or list or anything. A float 64, there's a chance there could be a missing number. So we have int, object, float, different types. The string is under the object. So there are different types we have here. So now we wanted to pick first two columns, right? So we say data frame, describe. So we are going to describe it, but we're going to grab only the first two columns. And this is only works for numerical values. So if it's not numerical, it's not going to work. So if I run it, it tells us for the P class, we have 309 rows that we expected. And the average value is 2.29. It doesn't make sense because we have P class. I'll show later on why. Because P class is basically first, second, and third class. There is no, for the categorical values, they are not useful. First boy, second boy, third boy, there is no average of it, right? If it was, number 1, 2, 3, we could average it. But then survived 0 and 1, we got the values, right? Now what you're trying to do is trying to see the first question is which feature has the most missing value. So we run data frame, is it null, and we find the count of the null, we sum it. And if you look carefully, the age feature has 263 missing values. For the Kevin, it's over 1,000. So basically, it doesn't have more data. And also the body, we have more missing data. For the boat, and home and destination have more values. So these are the informations. They have a lot of null values, right? And we need to deal with it. And it's natural to miss data because even if you have a computer running, there are instances where the machine could have a problem. It was shut down, so that no data was collected, right? Or manually data extraction was being done, but there were some anomalies there, right? So there is another technique. What we can do is trying to see which column has missing value or not. So data frame is null. We are doing the sum again, right? And now we are trying to see what is happening for the first 10 rows, right? And how many columns have missing values. So here is 2, here is 2, here is 2, here is 2, and 2 and 1, right? So what we do is we call a mask variable, and we call the data frame again and run is null if there is any null. If there is any missing value, you just tell me true or false. and it's saying for each of those rows it is true. That means every row has at least one missing values. That's why it's saying true. And if you look up, how many? One missing, one column missing, two column two columns missing, right? So if we put this inside the data frame and ask for the body column, right? Then you'd see the first row did not have value, second does not have value, two does not have value, four doesn't have value, only one, this one is has values, right? So this is the way we can actually pinpoint which rows has missing value, which has more missing values, and we need to deal with it. First, be aware what are the missing values, right? Then another thing we can do is we look into the categorical values. It means there are multiple type of values there. So we're looking into the sex and the result is male or female, and we're doing the value count. And you can see there male is 843, female is 466. So we know 80% or 60% of the data is male and female, right? Then we also look into another feature called embarked. It means from where they started, right? They either they start for Sherbrooke or Queenstown or Southampton, CQS, and we look at the count. So there are almost all of them has their embarkment from where they started. Two did not have the values, and we wanted to pick into another. So we're basically looking into toying around with different features. We look into the df.data feature, and we wanted to see the name, the first three, top three. If we wanted to see the bottom three, we would write tail. If I say tail, it will go the tail one. Okay. So if I run the tail, it gave me the last three, and we know there are 309 values, and it starts from 0. That's why 308. So if we start with the head, it returns from the very beginning A values, and we can write the tail, right? Now the question is, what we're trying to do here? We're trying to predict whether the person survived or not. And in the process of that, we're looking into which one has more missing values. And we can drop it, we can replace it with different values. But the first question is, does it relate it to our work? The name does not have to do anything with predicting name. The ticket number does not have any effect on the survival rate. From where the person started or destination doesn't matter, right? Which boat? Now there is important question, or cabin number. The question is, the boat and body, these two columns need to be dropped. The question is why? Because this is called data leakage. It means if a person has a boat number, it means we can say the person survived because the person got on a boat, right? Or if the person has a body ID number, it means the person died because there is a dead body number. So indirectly, the model will know which one survived or not. This is not good, because if there is any feature that has information for the prediction that we are trying to make, we need to drop them or modify it some sort, right? So this is important. The term is data leakage. We need to avoid this because otherwise, we'll have a model that really works. Another thing is that these two, if we introduce new data, this tool might not be there, right? So we need to work on that. And Kbin has more than 1,000 missing data, so this is easier to drop, right? So the second thing you can do is we're dropping few unuseful, unnecessary columns. Now we work with the remaining of the data, right? Now if we look after dropping them, if you want to print the df, let's run it, then we ended up with 8 columns. P class survived 1, 2, 3, 4, 5, 6, 7, 8, right? P class, and P class has first class, second class, or third class, right? Survive is either 0 or 1, either survive or not. Sex is male or female. The age is a number, this is a number, this is a number, this is a number, and from where they embarked, right? So these are the categorical values, and the problem is that first of all, a lot of machine learning models, they expect a number as input. Okay, so it's better to convert this information in numbers so that most of the machine learning model will work properly. Number two, a lot of model does not deal well with the missing data. So we need to get rid of the missing data. Two, okay. So pandas get dummies actually make things easier. What it does is it looks into the feature and it says if it has two different values, it will create two different columns for them. So sex female, sex male, two different columns. And for them, it will assign 0 and 1. Because when you want to create sex underscore male and sex underscore female, for the first row, for the female, it will assign 1. For the female male, it will assign 0. And if you look, it does that. It creates two different columns for this one. So this is a way to work with the categorical values where we have categorical numbers. For mbird we have 3 because it has sqc, 3 different ones, right? Then when we look, this is the way if we can look if we think the sex male doesn't have importance, right? We can drop them. And why is that? Because for the Titanic, all the males were left behind uh, at the Titanic, so they all died, we know. So it's better to look into the female and the children, so you can drop it, right? Or what you can do is when we do the get dummies, we'll see whatever you return, you drop the first one. So sex female, sex male, it will drop the sex female. Embark CQS, you can drop the first one or second one, right? So we can do get dummies, we can run it, it ran, we got the column name. From here we're dropping the sex male. Let's not run that. Let's see what happens from here. We will get dummies and drop the male, and if we run it, it drops the value, right? Why it did not drop? Okay, we'll look into that. But quickly, let's have a look. Oh. So this one, what it does is this one is working for individual rows, but for this one, what they're doing is they're working for all the columns that needs to be done, right? Then what we do is we divide the data set into two, x and y, and this is another convention. The capital X is representing the matrix that we have the data frame. It has all the information except for the prediction column that is survived, and we are trying to predict the y that is called df survived. So till now what we did is we look into the missing values. Then what we did was we drop the values, we convert the categorical values, and we divide into x and y. And as we already imported the required thing, what we need to do is we need to split the data set into multiple parts: training set and testing set. Why? So we'll train the data set with those and we'll test with the rest of them. So this is a convention. We have X train and X test. So these are the features for the training part, and this is the feature part for the testing, and this is the prediction train, prediction test, and model selection train test split method actually gives us. And we are importing the X and Y, and the training size, test size is 0.3. It means the training size is 0.7, so 70% and a 30%. The random state, what is that? So the split is always random, but if we keep this random state 42, it means we'll be able to reproduce it. The seed value makes sure that if we run it multiple times, it will be working properly, right? So we run it, then next string. So X column, we're looking into it. It will have all the information except for survived. X is the features that we're going to train the model with, and Y is what we're trying to predict, right? Now, to deal with the missing data, what can we do? The first thing is we can do is imputation. Or what does it mean? We'll replace it some sort of values. What can we do is we can replace with median value, mean value, or max values. So basically we are importing sklearn experimental, and we're importing enabling iterative imputer. Just keep in mind it's imputer, and you're providing with the name of the features. Why are these? Because this one has missing values, right? And what it does is it just simply takes the data and it fits and transforms the data. That's it. And basically fit and transform is to understand what the data provides and what's inside the data, right? So we are calling the iterative imputer, and we're calling the fit and transform. Fit and transforms are two different methods, but we're calling it together. So first it's fitting, and then it's transforming, and we are doing it with the training value. Nothing to do with the testing. Testing is separate. It's pristine. We're not going to do anything with it, right? And then we have the values. So now that we impute it, now we have to tell it which value we're going to impute it with, and we chose to do is median value. You can do it with mean value, right? Median is the middle value of the data set. So for the training and testing of the features, we are just simply replacing those data with median value. That's it, right? Another thing we can do is do standardization. What is standardization? Now let's go up. See, the fair value has 200, 151. So it ranges from 7 to 211. The age values, I think, between 0 to 99. So these two numbers, they have different ranges, right? And if you put them into graph, it will be really higher graph. So does it mean the model needs to give more importance to the fair because it has more values? No. That's why we need to make them standardized. So we can take these values and convert it into a range from 0 to 1, right? So it could be 0.29, right? The fair could be 0.211. But the make sure standardization is to basically convert the feature values between 0 to 1. So all the values, whether the big or small, they will be in particular range. So we go into the standardization. Again, we're calling a function from the pre-processing. We're calling standard scalar. We're again called fit and transform, and we're doing everything into the X-train and testing. Nothing to do with the feature one, right? And we fit and transform, and we can into a column, and we convert the data set. What it does is all the values will be between 0 to 1. So whatever that we discuss, we could easily create two different methods. This is optional, but we could create two different methods on it. What? So we have the initial data. We want to drop unnecessary columns. We do that and we call dot pipe. It means after doing this, you throw the result to this and to this. So you throw the data in with the pipe. What you're going to do, we're trying to get dummies. So we categorical data, we're converting into different columns and we're dropping first and returning the data frame. So two things at a time. Now what we do is we take those information, we split them into training and testing set, right? And then also what we do is we do the imputation, and also we do the standardization. Three things. So in the same method, this is not necessary. Again, you can do all those up here, but what it does is taking into the data frame, the name of the prediction column, and the testing size and standard columns. The first thing is to do is it's telling which are the numerical columns, because those which are numerical columns will take them and we can actually easily standardize them. You can't standardize categorical values, right? If it's something is male and female, how can you convert them into 0 to 1, right? So make sure that you have the numerical columns, right? And imputers also, it needs numbers, because if you're trying to take the median value of something, right, then what can you do, right? It has to be numbers. So this part is actually dealing with the numerical values, and this one is dealing with the categorical values, and we just call those two methods. The first one, we're calling it tweak Titanic. The tweak Titanic is here, is dropping and create dummies, and then we calling the get train text xy method. This one we're calling it, and it basically returns a training and testing set. So a lot of people, what it does is they just create a dummy classifier. A classifier doesn't do any machine learning things, but what it's trying to tell us is if there is a model and it has 1 in each 100 a negative class, so 99 positive class, 1 negative class. So if the dummy model is telling everybody is positive class, it will be correct 99 times, right? So we have a model with 99% accuracy, but that's wrong. To avoid that, we create a dummy classifier, and with any kind of machine learning model, we always call the fit method. Fit means it will take into those data, the training X and training Y, and it will actually fit into that model, and it provides us with a dummy accuracy. Okay, so let's call this method. Let's call this method, and it will return. Okay, because I did not provide that data set. Why it's saying name input was not defined. Okay. Okay, so we did not call it, so we have to call it here. See if it works now. Yeah, because the imputer was not called at the very beginning. So now it has that. So we call a dump classifier, and it has 0.57 accuracy. So it's not that we'll have 99% accuracy something, but to be honest, we just did something that all the other model will do. We import a dynamic classifier, we take the dynamic classifier and we train it into xtrain, all the features and the predictive features, and we find out the score, right? So now what we do is we import different machine learning models. We have dynamic classifiers, again we have logistic regression, tree based, decision tree. We have neighbor, k-nearest neighbor. We have negative bias. We have random forest classifier and XGBoost. So import all those. Just these are different kinds of models. They work differently. And then we call all of them and train them with the model. So what we're trying to do is basically we are by the way, PD concat, it just combine X train and Y test. So this is one, and Y is Y train Y test. This is basically Y, right? We're combining them. Concatenation means that we are combining those two information. And then we have the models, and this is what we're trying to do is we are splitting that data set into 10 different parts. That is, we are calling excuse me, k-fold. So model selection k-fold. So what we'll do is it will divide the data set 10 parts and make one for testing and rest of the 9 training. In the next iteration, it will leave that one that it used previously and use another one for training and testing purpose. And you already know that 42 is the seed values. And what we're trying to do is we loop through each of them, and the scoring value we look for is ROC-AUC curve. Okay, area under the curve. Okay, and we'll see how those model works. It might take a lot of time, but you know, let's do it. Okay, or why is not working? Keyboard. It's saying what is saying. Let's read. Setting a random state has no effect since shuffle is false. Should have random state to its default none or set shuffle equal to true. Okay, I'll set shuffle equal to true. Okay, and voila. So what you're trying to see, dynamic classifier is the curve is 5. Now it's dump, it's not doing any. Regression has area under the curve of 0.84, really good. Maximum is XGBoost classifier. So area under the curve, if you Google it, you'll see, you know, how much precision recalls are tugging each other and how much it's getting. So we have a model. What we do, I think I need to explain, is that we are just simply take different parts, 10 different parts of the model, and we're putting them into those classes, and we're training with it to X and trying to predict Y, and we're taking the AUC value, right? You could call it, what do you call it, recall, if you want. There are different ways to evaluate the model. Now it's reporting the recall values. And recall means out of all the original values, how many were caught. So now you can see if you look into it in terms of recall values, decision tree works better. Previously, when we are looking into ROC-AUC curve, we had XGBoost working better. Now what we can do is we can take all of this, take the good prediction values of all those models and combine them to get one output. So maybe we'll end up having a better result. Let's see. And stacking classifier actually does that. It stacks one of another. So all of this, we're taking it. Again, what's wrong? Okay, it cannot. Okay, but just to understand, we take all of these classifiers, and if we use the stacking classifier, it will go through each of them and do the same thing but report a result. But basically it combines all of the under the KLF, we have all of those, we put them inside it, and it will compare and work with those and report the result. Okay, another example is ensemble random forest classifier. This is also ensemble, it combines, but it actually combines results of different decision tree classifier. right? So if you can, I hope it's gonna work. Yeah, so random forest classifier, we're training it and fitting it and trying to see the score. And it has, still is not good, 0.78, right? Now we're trying to look into the precision score. When it make prediction, it's correct around 0.791%. And one of the good thing is the random forest classifier actually tells us which features has more importance, because we are using 8 different features, maybe not all of them are useful. And see, it's saying that the age and whether it's male or female and the fair has importance, more important based on the survival rate, right? And each of the machine learning models, they have some hyperparameters. It means they have some default values to set up, and we can tweak this based on the data that is provided so that the model can perform better. So it's more like we have a decision tree classifier, and we make sure that your leaves count will be 4. We can start off with 2. It depends, right? So we can, for this random forest classifier, we can look into the max feature. We look into from 0.4 and up to whatever auto. Then the random state is 42. It could change minimum sample leaf size, but you can basically put that and we can see if we can improve that model. And if we do that, this should take time, but the good thing is that we already have the answer. When we do that hyperparameter, it actually spits out. I think you're having a feeling that you need to know what to use and everything is there for you, but you need to do when and where to use it, right? So this basically tells us if we put the max value 0.4, minimum sample is 1, n estimate of 200, random 42, it will give us better result. See if it does. 0.70, no, it did not. So is we have to look for some other ways, right? So look, let's see what's going on inside it. So we are looking into the confusion matrix now. So confusion matrix basically it tells us the accuracy, the true value and the predicted value. So this one actually basically tells us like when there is 214 217, so the originally died 217 and machine learning actually predicted that true, right? And then we have 61. This is the prediction column, this is the actual column, right? This is TT, TF, true positive, true negative, false positive, false negative, right? You can Google a bit to understand the whole thing. And there are different other ways to look into it. We can look into this one and we will have a good chart. So this one doesn't make sense. That's why I was a bit, saying, I can't read this, but here you can see easily is that how many actually died? 217. These are actually died. So there are 217 plus 7% actually died. Out of them, 270 was correctly predicted as died, right? And 7 was actually falsely predicted as 7. So true, they died, but the machine learning model said they actually survived. Same thing here. 108 people actually survived. 108 plus 61 people actually survived, but prediction class 108 actually told them they have died, and the survivor class. So there are lots of wrong answers too. So these people were supposed to be here, right? And we look into the ROCUC score 0.66. It did not generate, but this one actually gives us an idea, and we can produce ROCUC curve on this. We can look into it later on. But what is the error here? Okay, something we need to run. I can check on later. The final part is that we can look into if we need more data to have a better result. Will that work? Right? So what it does is it's looking into um, different data size and trying to see if it's going to work or not. And it should provide us a nice curve and see if providing more data will give us a better result. And I think it's gonna take time a bit. It's running, as you can see. The final part is if we have a model, if you want to save it and use it later on. So import pickle. Okay, we have the result. So see what is graph is trying to tell us. It's trying to see the training instance was 400, 600, 800, 1000. The more data we provide, the cross validation score, we are looking to F1. F1 is a harmonic mean of precision and recall, and it improves. So if we give more data, the score will improve. And the score is F1 is 0.78, and we're seeing the curve is coming up nicely up. So it's basically telling us just take a chunk of code and you understand what's going on here. But it actually tells us more data will improve our result. So get more data. And the pickle one is we really like the data. This model, we want to save it. RF5, we just dump it and it's saved. If someone else is trying to have it, just load the data and it will work again. Basically simple as it is. As you can see, we just save it and we load it. We have 0.66. You know, I can go on and on this, but I just wanted to touch base so that you can get a hands-on on this code, ask questions, and try to see how this works. But basically, what it tries to do is it's trying to predict if people survived or not, right? And it actually did. And we have the confusion matrix. We went to different steps, and for the regression, we're going to go to the same detail, and I'll make sure more codes are running. But this is the way you'd learn. I hope this finds helpful. I'll share the link and see you on the next